Regression analysis models the relationship between a dependent variable and independent variables. It's vital for prediction, understanding causal links, and forecasting future trends. We can illustrate this with Python's Seaborn tips dataset. Using SNS, plot, we plot total_bill against tip, fitting a regression line. To enhance multivariate visualization, we pass "hue equals smoker, row equals time, and COL equals day". This automatically generates a grid of 4 distinct subplots. Each plot shows the regression for different combinations of time, day, and smoker status, revealing deeper insights into the data's complexities.
Regression analysis is a statistical method used to model the relationship between a dependent variable and one or more independent variables. Its primary goal is to predict the value of the dependent variable based on changes in the independent variables and to understand the strength and direction of these relationships. In simpler terms, it helps us determine if and how one variable influences another, allowing for forecasting and understanding underlying patterns.
The importance of regression analysis spans various fields, including economics, medicine, engineering, and social sciences. It's crucial for forecasting sales, predicting stock prices, understanding the efficacy of treatments, identifying risk factors, and making informed business decisions. By quantifying relationships, regression provides a powerful tool for data-driven insights and strategic planning. The provided Python code uses the Seaborn and Matplotlib libraries to perform and visualize regression analysis. It first loads the tips dataset, a common sample dataset in Seaborn, which contains information about restaurant bills, tips, and various customer attributes. The core of the visualization is SNS, plot, a function designed to plot data and regression model fits across a facet grid, making it excellent for exploring conditional relationships. The resulting plot is a 2x2 grid, with each subplot showing the relationship between total_bill and tip, along with separate regression lines for male and female diners. The rows differentiate between smokers, top row, and non-smokers, bottom row, while the columns distinguish between dinner, left column, and lunch, right column. This multivariate visualization effectively allows us to observe how the linear relationship between bill and tip, and the influence of sex, varies depending on whether the diner is a smoker and whether the meal was lunch or dinner.